Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
And welcome, or hopefully welcome back to another episode of Reliability Matters. Just like our last episode, we are recording in Anaheim, California, in sunny, quite warm Anaheim, California, at the Apex Expo in the Global SMT booth. Thank you, Trevor, and wonderful staff, David and Summer, for pushing all the buttons at the right time and making all this work. My guest today is, on this way too short of an episode, is Mark Kampurwala.
Very good.
He is the international sales god at Aven Electronics, or Aven's, not Aven Electronics. Aven is a solutions provider for binocular and tri-nocular stereo zoom microscope systems, digital microscope systems, numerous LED magnifier lights, and a wide variety of precision hand tools for the microassembly industry. Aven's key customer markets are just like yours. They are assembly, military, aerospace, defense, medical device manufacturing, and everything else that falls into that category. Did I sum that up correctly?
Yeah, you pretty much hit it all.
Hit it all.
Yeah.
So let's talk about digital microscopes.
Sure.
This show's all about reliability, so obviously inspection is a great part of reliability. In a world dominated by AOI, SPI, AXI, all the I's,
Yes.
the A's,
Yeah.
where they seem to be getting a lot of the attention, almost like the old Brady Bunch. Marsha. I mean, in your world, it's like, no, microscopes, back to basics.
Exactly.
What are some of the attributes that are uniquely beneficial for inspection that microscopes give you versus automated optical inspection and other technologies?
So really kind of where we sit is, the AOI machines, those are kind of go after the microscopes. We're more in the assembly production process. So that's where you would find us. And the reason why they still use the old-fashioned, you said binocular microscopes is in order to get that 3D view while you're manufacturing, you really do need a binocular scope. As much as they want to put stuff on a screen to kind of, make life easier for them, to cut down eye fatigue, you do need that binocular scope.
And help clarify something for me, and forgive my ignorance.
Sure.
Binocular, I get it. We have two eyes.
Two eyes.
Eyes too. Are we selling trinocular scopes to cyclopses? Or I mean, where does the third vision point come from?
So the trinocular scope, exactly, is, just like you said, it puts the image up on a screen.
Okay, so we have left eye, right eye, and
then a screen. So it kind of, you were touching on the reliability standpoint, right? The AOI, those are all documented processes where they get nice reports. Now with the trinocular scope, you kind of have that ability to document the reliability because all the cameras can take pictures, you can compare, so you're getting another quality check kind of on the production line before it actually leaves.
So when I was new in this space, in the electronic assembly industry, it was 1985, I was 24 years old, and we had binoculars.
Exactly.
Not binoculars, microscopes. And I remember just getting the focus right, getting the distance between your eyes set properly. You move a fraction of an inch too high, too left, too right, too far left or right, and everything goes out of focus. What has changed in the optical world? I mean, limit it to 10,000 things, but what's changed in the last many years that have made inspection through optical lenses more ergonomic, more accurate, less painful to the operator?
So from that standpoint, the same basics of a microscope, the design really hasn't changed. Obviously, the glass and that's improved. From the ergonomic standpoint, the head, the tiltability to adapt it to the user's eyes has changed. Where you get a lot of the ergonomics when we see in electronics and even like the medical device industry is when they're working under 8-10 hours a day, is that having that third screen, that trinocular port, a lot of the work you can do on the screen. And then when you really need to go see the 3D, you go through the scope. So you're really cutting down your eye fatigue that way.
Yeah. What are some of the latest advances in digital, not digital, but optical inspection and optical, just optical microscopes and things like that. What are some of the trends that are changing that, that area of our assembly process?
I think the biggest trend you're seeing is that, in the binocular scope area is adding that camera and the camera getting more advanced. Now the cameras themselves before, like, you mentioned it would go out of focus if you moved it. Now the cameras are autofocus where the chip automatically bounces and moves.
And they have like greater depth of field,
yes,
also?
To give you greater depth of field, to do some layering to where you can see right down to the bottom of something if you really needed to. So that's really where we see a lot of the advances. And obviously the ergonomics of the scopes just keep getting better.
And I would assume if you can increase the depth of field, now you have the ability to turn your inspection device into like an oblique viewer. You can actually rotate the board. Mm-hmm. That was always a struggle with old school microscopes. Once you try and put the board on a 20-degree angle or something to maybe look a little bit underneath the component, everything goes out of focus. But with a greater depth of field, that gives you a lot more margin, right, to play with.
And we have oblique viewers on actually our newest microscopes that we just, the second version that we introduced here at the show, actually has an oblique viewer that's a 360, so you can spin it around the whole object and get a complete 360 view. And because it has a screen and all the electronics now that goes with it, you can take a video, you can take a picture at any angle to record it.
How important is lighting with modern camera-based optical systems?
Well, lighting, again, I think it's always been, it's what makes or breaks, especially with, boards that are, that could be more reflective. You can put a polarizer in. So we have a whole bunch of different lighting options, they're coming in from an angle, coaxial that goes actually through the lens, depending on, what you're looking at. Right. We also have the, the ultraviolet lights, defense and aerospace boards all have the conformal coating on them. So you want, a UV light at 365 nanometers.
Right. And what are some of the common mistakes people make that just won't die? The mistakes just live on in perpetuity when selecting an appropriate scope for their needs.
I think from a microscope, the mistake a lot of times can be, not taking a look under the hood of what's inside. A microscope from the outside may all look the same, but the gears and, all the internal workings, if it's filled with a lot of grease, for example, your lenses will slip, and, it works on a two-lens system. If one lens is slightly higher or lower than the other one, you'll start getting double vision and headaches. So it's really important to, to kind of open it up. It's, is there a lot of grease that's going to, deteriorate over time to make the optics go out of alignment.
Headaches and double vision sounds like an average night after an expo in the hotel bar, right? We don't need that, right?
Exactly.
We don't need that at the workplace. Well, Mark Kampurwala, thank you so much for this very brief conversation.
Exactly.
I really appreciate it. And it's time to leave the comfort of these beautiful chairs and go back and stand in the booth, right?
Exactly.
All right. For my audience at home, we'll be back in just a few minutes with our next guest.
Synchro. Join the revolution. Non-stop selective soldering. Increase UPH. Reduce maintenance. Small footprint. Contact us today for more details.